I'm going to piggyback on the last video that we did whenever we did systems of linear equations in two variables. Today, we're just going to add an extra variable on there and see how much longer these problems get. So instead of just having an x and a y today, we're going to have an x, a y, and a z. Okay, now those variables we're going to change later with a word problem, but for now, just assume everything's in x, y, and z in that order since it says ordered triple. And so we're getting into three-dimensional planes here. I'm not going to worry about drawing anything like that on this video, but rather just see how, just look at the math behind this. And you can definitely do some searches on YouTube and the internet to see how this works with more of a geometrical interpretation with planes and such. So this is just x, y, and z. So deciding whether or not these three equations right here intersect at the point 3, -1, -5 is just going to be a yes or no, determined by what happens when I plug in 3 in for x, and I plug in -1 in for y, and I plug in 5 in for z. See if that equals -3. Okay, so just kind of going in order here. Did I mess up somewhere? Yeah, it's a -5, isn't it? Use parentheses, don't use parentheses on that. Either way, I'm going to get 2 minus 5 equals -3. So yes, it does work on this. Okay, I don't want to write yes or no yet, so I want to go through and check them all. Okay, so checking on this next one right here, I get 2 times x. Well, that would be 6. -3 times -1, that's a +3. And I have a 6 times a -5, that's a -30. Let's see if that equals -21. 9 minus 30, and -21 equals -21. I'm good so far. Yeah. Still not ready for a yes. I got to make sure it works on all 3 of these. This one I'm just going to put right underneath here. So I got -3 times 3. It cut me a break here, and they did not give me a z. Maybe for a little bit shorter of a problem. And yeah, I get -14 equals -14. So I'm good. If I get all 3 of these to work, that's the only way that it is a solution. Once one of them doesn't work, just like yesterday, the whole deal's off. No, it is not a solution to the system. Now this is going to be a little bit more tedious than what we did yesterday. A couple different ways I'm going to solve them on these, but the way I'm going to start all these is I'm going to try to pick 2 equations. Doesn't matter which 2 equations, and I'm going to look to use the addition method that we did yesterday to eliminate a variable. Now this next step is where I lose a lot of people. What I'm going to do is I'm going to choose another pair of equations. So if I chose the first 2 equations, I might choose the last 2 equations next. And I want to, again, use the addition method. Here's the key, to eliminate the same variable. We did the practice from last night. By now, when we get down to step 3, we have a problem that looks like last night. I can use substitution, I can use the addition method, elimination, whatever you want to call it, and I can find out what x, y, or z is. And I'm just going to do my back substitution until I get back to the original problems and get all 3 of my variables. Here we go. Hang on. This is going to be a ride right here. Okay? So first order of business I do is I really try to stay tedious with this problem and make sure I can follow all my work. So I'm going to be numbering my equations to help you as well. So looking at this, I'm looking for stuff that cancels. I just noticed right off the bat these z's right here. They would cancel very easily. My last hour didn't see that. They were looking at the y's and they got y's to cancel, and they're still going to get the same answer that I'm going to get on this one. So if I just add equation 1 and equation 2, I'm not going to bring them over on this one. Rather, I'm just going to add them vertically right here and bring them up. I get x plus 2x. That's 3x. I get 2y minus 4y. That's -2y. The z's cancel, and I'm left with -10. Again, I didn't rewrite anything on this. I might do that on the next example, just because they were already side by side and they canceled so easily. I am going to give this a new name though. Okay, I'm going to call this equation 4. So I'm needing one more equation. I've done step 1. I've eliminated a variable. Let me go through and clean this up a little bit so you can kind of see what we're going to be doing next. What I want to do now is I don't want to choose equation 1 and 2 again. I either want to choose equation 1 and 3 or equation 2 and 3. And I'm looking to eliminate the same variable. So I'm wanting to eliminate the z's again. I look at it, I see these two would probably eliminate the easiest. So if I bring over equation 2, but I'm wanting it to cancel with this z down here at the bottom on equation 3, I'm going to need to multiply equation 2 by 3 throughout the whole thing. So it's going to be, that's going to change equation 2 to 6x minus, let's see, I'm multiplying by 3, 8y, I knew I was going to say that, 12y, plus 3z multiplied by 3, negative 21. I have to keep reminding myself when I'm multiplying by. Negative 2x plus 2y. Equation 3 just gets to pop on over because the z's are already going to cancel on it. Okay. Again, these canceled. I'm left with 4x minus 10y equals negative 17. Hope that's right so far. I'm just going to double check myself real quick. Yeah, I'm feeling that's all right. Okay, so I'm going to call this equation 5. Equation 5. Now I want to look at equation 4 and equation 5, and even though they're not stacked up, you can stack them up if you need to. Equation 4 and equation 5, I'm wanting to use substitution or the addition method to get rid of another variable, okay, to solve. This is just what we did last night, except for instead of, I guess we do have x and y because the z worked itself out. I think if I just multiply, I'm going to bring down equation 4 right here, and if I just multiply it by negative 5, I think good things will happen with it. So let's try it. So equation 4 multiplying by 5, negative 15x plus 10y equals 50. It's a really bad 5. There we go. And since I did that, I think I can just bring over equation 5 right here, and hopefully you kind of see why I chose that number now, is that I am going to get the y's to cancel. And I have negative 11x equals 33. Feeling better about this problem now because I'm getting a nice number that I knew I was supposed to get. Divide both sides by negative 11, and I get x equals negative 3. Wow, that's a lot of new stuff right there, but big sigh of relief whenever I get to right here because I've done the beef of the work, okay? Let me just backtrack what I did, okay? I eliminated these z's to get equation 4. I chose 2 other equations where I could eliminate the z's, did a little bit of work with it to get equation 5. Once I got equation 4 and 5, I just used my work from last night that I did. I used the addition method to eliminate the y's to get my x. Now from here, I'm just going to do my back substitution. My back substitution is going to, if I know that x equals negative 3, I can find y right here by just plugging negative 3 in for this x. So I get negative 12 minus 10y equals negative 17. I'm going to add 12 to both sides. So I get negative 10y equals negative 5. Divide by negative 10, I get 1/2. And I got a fraction. It's not a bad fraction though, so I'm not feeling too terrible about it. I have my x, I have my y. Again, I'm going to back substitute both of these back into an original problem. Which original problem? It doesn't matter. I've had all my classes so far today have chosen to substitute back into 1 because that has the smaller numbers in it. So if I plug in my x back into equation 1 right here, I get a negative 3 plus 2 times that 1/2. That'll be nice. That'll go back to a regular number. And I'm just going to solve this for z. So I get negative 3 plus 1 minus z equals negative 3. Hopefully now you see why I put lines in my z's, because my z's and my 2's look very similar otherwise. Z equals negative 1. Divide both sides by negative 1, z equals 1. Wow. A long problem here, but we've got our answer. My answer is the ordered triple, -3, +1/2, and 1. Okay, brought it up, x, y, and z. You can definitely check that if you want to, same way we checked example 1 to see that it was a solution. Let's see a couple other different ways this can be asked. Now on this one, I'm going to number my equations a little bit different. 1, 2, and 4. Where did equation 3 go? Well, I'm looking at this. They threw me a bone on this one. They said, you know what, we'll go ahead and eliminate the z for you so that you've already got equation 4. So I just need to work with these other two equations right here. If I add them up, my z's will cancel again, and I get my equation 5. 3x plus 2y equals 3. I've got my 4 and 5. That was much quicker if they shorten one of my equations. That'll happen again later. So looking at this, if I can multiply, if I bring over equation 4 but multiply it by -1, I should get some variables to cancel. And oh man, sure enough, I got way too much to cancel, didn't I? I got it all the way down to 0 equals 3. I got it all the way down to a statement that is not true, meaning that there is no solution to this. Oh, we like no solutions because it makes this problem so much quicker. I am done with it now because I got no solution. Okay. Now you probably know me. If you know me well, you probably know what's going to follow a no solution. So I'm going to let you go ahead and work this one. Take it as far as you can, and I'll work it down to a stopping point as well, and we'll see where we can match up at. Okay, so go ahead and hit pause. Just like you might have guessed, this one is going to be infinitely many solutions. Took me a little bit longer to get there, and I used a substitution on this. Hope you can follow my arrows. I went ahead and eliminated my y's first up here in the blue, and then I came over. So it's infinitely many solutions. So your answers in the book are going to have your solutions as in terms of x. So you'll have x, and then you'll have y in terms of x, and you'll have z in terms of x. And so in order to get to those answers, we can just, again, do a back substitution. I'm going to come right here to get my z, find out what this z right here is equal to. And so if I add 2 to both sides, I get 5z equals x plus 2. Solving this for z, I get 1/5 z plus, I'm sorry, 1/5 x plus 2/5 equals z. And that's exactly what I'm going to pull down right here in place of my z. It's a little bit weird right there, I know. I don't have y anywhere on the board that I wrote except for right here on the original problem. Okay, so everything's in terms of x. I don't have anything to plug in for x. I'm wanting to solve for y, but I did just find a z. Okay, my z in terms of x is 1/5 x plus 2/5 equals 1. You're very tedious here with this math. I messed it up a while ago. Feeling good about it this time, though. And so bringing this over, I'm going to come over to the side so I don't run into my problem. X minus 1/5 is 4/5. Still have the y I'm looking to solve for because that's what I'm wanting to put right here in this spot. If I add the 2/5 over, that gives me 7/5. So subtract the 4/5 x from both sides. I just divide everything by -1. Man, that is a nasty y, but that is what it is. So definitely going a little bit above and beyond to get this over here. I'm more interested in this infinitely many solutions, but this is going to be of interest on these infinitely many solutions as well. All right, picking up on my favorite Christmas movie as a child, it had to be A Christmas Story. We did not have Will Ferrell running around as Elf yet. We didn't have Jim Carrey running around as the Grinch. Those are two great Christmas movies. I had to go with A Christmas Story. I'm not quite as old as these guys. This is a little bit older than me, but it was just on TBS all the time, so I just couldn't help myself. And I know about every line to it as well. Pretty good stuff. So a movie theater charges $8 for adults, $4.50 for children. Ooh, I'm adding that third variable today. $6 for senior citizens to watch their feature film, A Christmas Story. Okay, just for ease, I'm just going to change my X, Y, and Z to A, C. I'm going to be super careful with my S so it doesn't look like a 5. A, C, and S. To watch their feature film, A Christmas Story. So one day, the theater sold 405 tickets. That means if I take the number of adults plus children plus senior citizens, it equals 405. Got my equation 1. And they collected $2,320 in receipts. So not much different than the previous video where I can just take the $8 that each adult paid, the $4.50 that each child had to pay, and the $6 that each senior citizen had to pay. Came out to be $2,320. Need that third equation. I have 3 unknowns. I need 3 equations. Here we go. Twice as many children tickets were sold as adult tickets. So twice as many children came as adults. That means if I take the number of adults that came, multiply it by 2, it should equal the number of children. Think of it this way. Twice as many children tickets sold as adults. For each adult that came, 2 children came. So I've got to multiply all the adults by 2 in order for it to match the number of children that came to watch the movie. And now I'm just got to solve this. I want to know how many adults, children, and senior citizens came. Okay, let me get a blank slide up here. Those equations. Now this one's a lot different, right? Because look at my equation 3. My equation 3 is very simple. Okay. Anytime I have an equation 3 that is solved for a variable, I think it's going to be easier if I just take whatever variable is being solved for and plug it back into equation 1 and equation 2. So equation 1 would turn into A plus, instead of C, I'm going to put 2A, giving me 3A plus S equals 405. I'm going to call this my equation 4. Now, whenever I plug it back into equation 2, you know where I'm going to go with it. $4.50 instead of C, 2A. So we get 8A plus 9A plus 6S equals 2320. I can take that a little further. Oh, I messed up something. No, I'm good. 17A plus 6S equals 2320. And now I have equation 5. Now, thinking back to this video right here, I don't think you've solved anything from equation 4 and 5. So I'm going to let you got some options here. I've worked it both ways today, both addition method and substitution. So I want you to go ahead and try to wrap up this problem and find out how many people came that were adults, children, and senior citizens. Go ahead and pause it, and then I'll have my workout. Didn't work it all the way through, but you can watch the rest of this to see if it does match. I think it was easiest to solve for A first. If I come over and look at equation 4, I have an S by itself, so I solved for S and did a substitution property into equation 5. From here, I just have back substitution. Okay, so I'm going to bring this A up, plug it in right here. So my senior citizens is -3 times 110 plus 405. Let's do that math in my head. -330 plus 405. That's 75 senior citizens, 110 adults. And man, I love equation 3 right now, because to find out how many children came, all I have to do is take the number of adults and double it. 220 children came to watch my favorite childhood movie, Christmas Story.